Okay, we're talking about the derivative. We're in 2.1 still, in 2.1. 2.1. And this is it, right? This is our life for the next 18 weeks, right? Actually, until we actually take the AP exam, but then we're gonna, actually at the end of the semester, we're gonna do something called integral calculus. Right now, we're doing something called differential calculus based on something called the derivative. And remember, the derivative, the idea of the derivative is that it's the slope of the function at one point, not two, right? At an instant, okay? Now, basically, we've been focusing on the analytical, or basically using algebra to arrive at the derivative. But there are two others that are on the exam, data and graphing. So what we want to do now is we want to look at one of each. This makes up most of the class, no doubt about it. You're going to do analytical derivatives most of the time. Data is probably the least of the three. Like this is probably like 75% of the course, this is like 5% of the course, and this is like 20% of the course, 25% of the course. So let's just do an example of finding a derivative using the definition, the analytical. Suppose, and that's what we're going to do. We're gonna, basically we're going to talk about derivatives here. Okay. So suppose that's the derivative. What would the derivative be? Well, I know the definition, right? Limit as h goes to 0 of f of x plus h minus f of x all over h, right? So then you just got to put that in. It's kind of a pain, right? Because we have f of x. What would f of x plus h be? F of x plus h would be x plus h cubed plus 2x plus h squared plus 5x plus h plus 4. Uh-oh, running out of room here. There we go. So, notice this is kind of, this taking derivatives is kind of a pain by doing it by the definition, okay? Now, in 2.1 and 2.2, we're going to do it by the definition. What's going to happen in 2.3, 2.4, 2.5, 2.6, we're going to actually come up with shortcuts so that we don't have to do this, okay? But just to be clear, all derivatives analytically until we get 2.3 are done this way. And you can see it's going to be horrible, right? So the derivative would be the limit as h goes to 0 of f of x plus h, which is this giant thing, x plus h to the third plus, hold on. Plus 2x plus h squared plus 5x plus h plus 4 minus the original function f of minus the original function 2x squared 5x plus 4 all over h. That is the derivative for that function. That's the derivative. But what we're doing is we're taking the derivative for this particular function. And the algebra is pretty ugly here, right? I got to FOIL that out. X plus h to the third. And again, that's going to be x to the third plus 3x squared h plus 3x h squared plus h to the third. That's if you FOIL it out. Now, you can do it by binomial expansion, or you can do it by just x plus h times x plus h times x plus h. But you got to work that out. And then here, 2 times x squared plus 2xh plus h squared plus 5 times x plus h plus 4 minus x to the third plus 2x squared plus 5x plus 4 all over h. It's pretty huge, isn't it? So then now let's distribute the 2 and the 5 in. So what do I get? X to the third plus 3x squared h plus 3x h squared plus h to the third plus 2x squared plus 2x h, oh no, 4xh. Sorry, I'm distributing that 2 in. Plus 2, sorry, that's the h squared here. Plus 2h squared plus 5x plus 5h plus 4 minus x to the third plus 2x squared plus 5x plus 4 all over h. Now here's where we catch a little bit of a break. Everything in the back end here is going to cancel. Because of the h thing, right? I gotta get this h to cancel, so every term without an h has to die a horrible death, right? So now I have 3x squared h plus 3x h squared plus h to the third plus 4x h plus 2h squared plus 5h all over h. Now you'll notice everything in the top has h in it. Cancel it out with the one on the bottom. So kill, 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 kill. So divide an h out. Now some people factor the h out and then divide it, up to you. 3x squared plus 3x h plus 4x plus 2h plus 5. Now this is the one step that students tend to forget. The h is going to 0. So you can actually get rid of these ones too. 3x squared plus 4x plus 5. Finally, we got the answer to the question. This is the derivative. Again, remember how we found this derivative is we used the definition, and then there's my f of x. And you don't have to write this down, but I did here. Here's the f(x) minus f(x). So this is the definition of the derivative for that function. And then you just got this obscene amount of algebra. So that's the analytical one. It's the most annoying of them. There's no doubt about that. Okay. It is by far the most annoying of them. Okay, so let me move down here. Now, this is probably the nicest of the three. Data is kind of unique. It's called data discrete math. If I give you, now, I kind of messed up here, but I did it on purpose just to save myself a little bit of time. Suppose, you have to imagine this. Suppose I give you this data, but you're not looking at this, okay? What would the derivative at 2 be? Now here's the thing, when I give you data points, or we call it discrete points, you can only use these points to solve the question. Now what's important about data questions, sadly, is we can't actually find the derivative. We can only approximate it. And what we're going to do is go back to the old-fashioned definition of slope. Here's how we're going to do this. We're trying to find the slope here at 2. Okay. What we're going to do is, I'm supposed to take the limit as x approaches 2, right? But I can't do it because I don't know anything else. What you're going to do is you're going to take the 2 points around 2, and you're going to take the points around, the 2 closest points to 2. Remember, we're trying to get really close to 2, but we can't because we only have these 5 points, right? So what you're just going to take the 2 points closest to 2, and find the slope of that line. And we're going to argue that it's at least probably, hopefully, close to the actual slope. So keep in mind here, what we want to do here is we want to find this derivative, but we can't because in point of fact, let's just kind of make sure we're clear about this. We don't know about these green points. So the thing is, we only actually know about the data points, and I can only use the data points. So if I want to approximate the derivative here, I'm going to use these 2 points here. So it's not that hard. So you're going to say f of 3 minus f of 1 over 3 minus 1. We're going to use old-fashioned slope because I can't take any limits because I can't get close to 2 because I don't even know what 2.1 is. How am I supposed to find 2.0001? I mean, so, but you might go, oh, the good part is this is almost like a freebie, right? It's not super hard. 100 minus 20 over 2, 80 over 2, 40. So that the derivative at 2 is 40. So there's a data type question. Data questions are usually easier because you're not going to actually find a derivative, sadly. You're going to approximate it by picking the two closest points, one on each side of whatever point you want to find the derivative at, and then you find the slope of that line, and then you can argue that that's going to be the derivative. Well, as close to it as we can get. Okay, graphical. What if I draw a graph of a function, but it's actually continuous, so it's an actual continuous graph. We'll call this f of x. And this is just an example of a graphical question. Suppose I ask you, you got a derivative at 0, a derivative at 1, and a derivative at 2. Put them in order from least to greatest. Here's how you do this one. You say to yourself, well, the derivative is something like that. Notice I don't know what the number is. I don't know what the number is. I can see that as the derivative. And then here's the tangent line here, so there's the derivative there. And then here's the derivative here. Now here's the kind of interesting thing. I don't know what the numbers are, but I still can put them in order, can't I? Right? You see, I don't know what the derivative at 0 is, but it's clearly going up. If the function's going up, that means the slope is positive, isn't it? Here, the derivative is 0, or very close to 0. And here, the derivative is negative. So notice that I can actually put them in order. This derivative would have to be the smallest derivative, and that derivative would have to be the biggest derivative, and that is going to be between it. Now, this is very often how the AP exam will do it. They'll ask you to put 3 derivatives in order, and what you'll know about the derivative is one is positive, one is negative, and one is 0. It gets a little trickier if you have multiple positives and multiple negatives, because you kind of then have to look and see which one's the steepest and which one's the least steep. But so they tend to avoid that on the exam itself. Okay, so there's the 3 ways of, so we learned the derivative. So let's go back down. We learned about the derivative. And then there are 3 ways that we deal with the derivative. One is doing all this algebra. The other is if we just have data and then you don't really do the derivative, you just use slope. And then last but not least is what if I give you a graph? And we're going to spend a little more time on the graph one, okay? Okay, enough for today.